Hi, my name is Massimo Banzi, and I like to make stuff. So today we're here to look at another project from our Arduino starter kit. Today we're making the spaceship interface. This is a simple project designed to teach you about simple inputs and outputs with Arduino. This circuit is going to show you how simple it is to connect a small button and a set of LEDs to the Arduino board, and how you can control the LEDs through the button. First, I want to explain to you a few concepts about Arduino. First of all, Arduino, it's a small computer the size of a credit card, as you can see here, that we can program using the Arduino development environment. I'm going to show you in a few minutes. So the idea is that we write instructions in the development environment, then we press a button that gets turned into a program that gets downloaded into the Arduino, and then the Arduino can interface with the outside world to implement any crazy project that you can come up with. So this project is very simple. We have a button connected to pin number 2 on the Arduino, and then we have 3 LEDs connected to pin 5, 4, and 3 of the Arduino. When I press the button, these 2 LEDs that are now blinking will stop blinking, and the yellow LED will turn on. If I release the button, the 2 LEDs will keep blinking. So this is a very simple circuit that allows us to control the behavior of these 3 LEDs from this button. Let's have a look at the code that we need to implement this behavior. At the beginning of the code, we have this line that says const int red LED 1 equal 5. So this creates a constant called red LED 1 that contains the value 5. This is actually a very clever technique that allows us to give a meaningful name to pin numbers. So throughout the code, I don't have to use numbers, but I can use red LED 1 to remember that that particular pin is associated with the first red LED. And if you look, there are another couple of lines where you define a constant for red LED 2 and green LED. Then later on, we have another constant called switch pin equal to. This specifies that the switch or button that we're using is connected to pin number 2. Then let's look at the setup. The setup is that part in your Arduino code that gets executed once when the board is powered on or reset, or this means also right after you upload some code into the Arduino. And so as I said, this gets executed only once. So we see the instruction pin mode. Pin mode basically tells Arduino that we want to make sure that pins red LED 1, red LED 2, and green LED are all configured as output, because the input and output pins of the Arduino can be configured to assume both configurations. Then we have an instruction called pin mode, switch pin input, which is used to specify that the pin number 2 is connected to a switch, and then we want to make sure that that's an input so that we can read from it. Now, let's have a look at the loop section. The loop section in your code gets executed over and over as long as the board is powered on. So we create a variable called switch state, and then we say switch state equal digital read switch pin. So basically what this does, reads the state of the pin connected to the push button and returns the value high or low, depending on the fact that the button is pressed high or released low. Then we're going to use a clever statement called if, which is very important whenever you write some code, because it's the statement that allows you to make decisions. So in this particular case, we basically ask Arduino, if the switch state is equal low, do something. So in this case, we use the curly bracket to group lines of code together. So you can see that the if statement is followed by a question, a condition that needs to be verified, and then a curly bracket that specifies which lines of code need to be executed when the condition is true. In this case, switch state equal low basically says if the button is not pressed, and then we follow that with a series of digital write statements that are used to turn on and off the LEDs and to implement this particular blinking behavior. After that, we have a delay of 250 milliseconds, followed by a short blink cycle that happens on the other red LEDs. So the instructions that you see in this section of the if statement are used to implement this blinking behavior that you see here. Afterwards, there's a statement called else. Else is a statement that allows you to basically create a fork in the road in your Arduino code. With if, you can say, if something is true, execute this piece of code, and else says, if that condition is not true, then execute this other piece of code. So you can have two different parts of your code that gets executed depending on the condition, if that condition is true or false. In this case, when the button is pressed, then we use two digital write to turn off the red LEDs, and we use one digital write, green LED high, to turn on the green or yellow LED like we have here. So if I press the button, the LED turns on. If I release the button, the LEDs are blinking. So this is all the code that we need in order to implement this behavior. I want to remind you that the code that's inside the loop statement will be executed over and over. So as you can see, the blinking pattern is executed, then Arduino reads the input, checks if it's true or false, and depending on that, decide which behavior to implement, and then loops back to the beginning. That's all for today. I hope you enjoyed the tutorial, and remember, build it, hack it, share it, because Arduino is you.